In the last episode, I showed the full setup at a very high level, just to show you how it potentially could work. Today, we're slowing things down and doing it properly, step by step. I'll explain why your CI behaves differently from your local setup and how Terraform helps QA fix that with clean and consistent environments. So let's go. As QA, we all know the pain, right? You're waiting on deployments or either sharing environments with other teams. And in the meantime, the test data is inconsistent, which creates slow feedback cycles for your team. But what we actually want, guys, is very simple. An environment we don't have to wait for. One that is ours and is isolated from the rest. Something that can actually build itself automatically with, in this case, predictable data. And that is what finally gives us quick and reliable feedback early in the process. As you see, we QA people aren't that complicated. We just want a proper environment. Running Docker Compose locally always feels smooth because everything is under your own control. Your data is clean, the application responds laser fast, and things behave exactly the way you expect because you're using your own configs and your own test data. But in the CI, it's nothing like that. Your folder is clean, but the machine isn't. Other pipelines leave behind Docker state, slow things down, or even change how services behave. And next to that, the pipeline uses its own config and test data sets. And it all runs in a fixed way that you can't control the same way you do locally. So something that looks perfect on your laptop can act completely different in the pipeline. So in order for you to follow along, you'll need Terraform and the AWS CLI installed. You can install both with Homebrew on macOS or Chocolatey on Windows. This is the first step for QA in taking real ownership of environments. Now let me walk you through this Terraform file and show you the foundation of our future test house. It won't be furnished yet, because this episode only focuses about building the structure. At the top you see a part called Provider. This is where we tell Terraform where to build our dynamic test environment. It's simply defining the cloud provider and region where our test infrastructure will live. In my case, I'm using AWS, however, it could also be another cloud provider. It's good practice to specify a region that is close to your location, in my case, EU Central. The real benefit for QA in this case isn't the provider itself, it's that Terraform lets us create an isolated test environment on demand. In the data block, we define the operating system. Here we just use a Linux Ubuntu image for our dynamic test environment. By using this fixed image, every run starts from the exact same baseline, which removes those classic "it worked yesterday" issues for QA. Then we add the basic network rules. In the security group section, we are only opening the port for SSH at this point. In a real-world setup, you'll add more specific rules to ensure not everyone can reach your application. So because all the rules are defined in code, it's easy for anyone on the team to understand how the environment is actually set up. In the instance section, we are going to bring everything together. We're going to set the VM size and reference the Ubuntu image and security group we defined earlier. On the right side, you can see how the instance directly uses those names, ubuntu.id and qa_sg.id. Then next to that, we have the VM size, which depends on your application. And we have the SSH key name, which in this case refers to a key that is already created in AWS. The SSH key allows us to connect to the newly created dynamic test environment. Terraform then builds a clean VM from these pieces every time, giving QA a fresh and predictable environment. In episode 4, we'll furnish this test house with Ansible. And finally, we output the public IP so we can connect to the environment. Each run gives us a new IP, but the machine itself is always fresh but identical. For QA, this means we can reliably work with a clean test environment every single time. Now that we've walked through the entire file, let's actually look at the commands we're going to use to actually create this environment step by step. To follow along, you'll need an AWS SSH key. This key lets you connect to the virtual machine that we are going to create. If you don't have one yet, you can create it in the AWS console under EC2 key pairs and download it to your machine. Once it's on your machine, move it to the .ssh folder. In the Terraform file, you'll see a field called key_name. That's simply the name of the key pair you created in AWS. Terraform will use that name so the EC2 instance knows exactly which key to trust when you're trying to connect. With this key, you wouldn't be able to log into the environment at all. Now we're all set, let's try to actually create the dynamic test environment with Terraform. Terraform only needs a few steps: init, plan, apply, and destroy. With Terraform init, we initialize the project and download the providers that Terraform needs. In my case, this is going to be AWS, as I explained before. As you see, in the folder that I'm working, a new Terraform folder has been created after we run the command terraform init. Now I'm going to run the command terraform plan. This will show what Terraform will actually create or change in the cloud before anything actually happens. I would always recommend running this step so you can actually see what will be created or changed. As you can see, this output reflects the exact same configuration we defined earlier in the Terraform file. Now we are going to run Terraform apply, and this is where it gets really exciting. Terraform is about to create our entire environment in the cloud. Now the environment is created and you can actually see the output we defined earlier in the Terraform file. Terraform prints the public IP exactly as we specified in our output block, and this is the IP we are going to use to connect to the actual machine. And now that we've obtained the public IP, let's actually check if we can connect to our dynamic test environment by SSHing into the machine. Since this is our first connection to this new machine, SSH asks us if we want to trust the host fingerprint. That's normal for a fresh VM, so just confirm with yes. Congratulations, you've just created your first real test environment. And to make this moment even better, let's copy some files from the repository onto the machine so you can actually see that everything works as expected. Next, I'm using SCP to upload a file to the dynamic test environment. SCP is basically SSH for file transfers. I'm sending a Docker file from my local repository into the dynamic test environment's home directory. I'm only doing this to show that we can already interact with the environment we created, so you can already start playing around with your new machine. We're now going to connect one more time to the dynamic test environment to check that the file was successfully copied from the repository to our VM. You'll see that it's the same Docker file sitting there, and we can confirm this by running cat docker file. And finally, we are going to use Terraform destroy. We're going to clean up the test environment again. This will keep our workspace tidy and will avoid extra cloud costs. So always after we're done testing, we can clean up the environment because we don't need it anymore. You've just seen how Terraform creates a fresh, predictable test environment on demand, and how this solves a big, real problem that QA teams face every day. Now let's look at why QA needs Terraform. So why does QA need Terraform? Because unstable environments create unstable tests, and Terraform fixes that with 3 key benefits. So let's go through them. First, a fresh environment on every pipeline run. No leftover data, no shared state, and no surprises from previous runs. Every pipeline starts clean, exactly like the VM we just created. Second, a reproducible setup everywhere on the same network with the same configuration in the same infrastructure, whether you run it locally or in the CI. This consistency is what makes test results predictable. And third, we can finally test in a merge request and not after. QA gets reliable feedback early instead of waiting for DV or AT environments that may not even match production. These 3 things together are why Terraform becomes such a powerful tool for QA. We just created a full test environment with Terraform, step by step. And we improved on the last episode by separating the building of the house from furnishing it. In the next episode, we'll focus on how to properly furnish that house. Thanks for watching and see you next time, guys.